This is in our book. It's chapter 2.3. And there's a chart on page 168 that's going to help you a lot. So like when you're practicing or studying or whatever, that can help you a lot. Yeah. Yeah, because you got to do, like, in the chapter, it asks you to do stuff like sketch graphs of things like x cubed minus 3, or like, I don't know, let's see, another one would be x plus 1, or x squared plus 1. So yeah, I'll walk you through that chart today and hope and see if it helps you make sense. But it's one of those things, like, it'll make sense today, but then you're going to forget it.
Yeah.
So that's where the chart's helpful. Yeah. So we'll go over all that. All right. First part is kind of confusing. Man, it's tricky. It's tricky also because, such a big class today, right? How are we gonna keep it under? How are we gonna keep it all under wraps, right? Yeah. Hey, Johnny, shut up over there. Man, all right. So we got two things on our agenda. Let's see if we can make sense of this. So, domain, and right here we'll do range. So here's what I'm thinking, Ernesto. I'm thinking I'll tell you what they are, and then to show you how to kind of like answer the questions about them.
All right.
So what domain is? It's going to be like a list, a set. It's going to be all of the numbers you could, that's supposed to be an L, or you could use as an input for X. And that probably doesn't make any sense.
All of the numbers
that you could use for an input for like some function, right?
Yeah.
So yeah. So like we'll give you an example. Like if we had a graph. Let's say we had a graph, and let's say it only went from, let's say like this was -4 and this was +2. So let's say we had some graph that went like this. Like that. I know that's funky, right? That's funky. That's ugly. All right, so here's the thing. All right. Man. This is one of those things. This is one of those things that's hard to teach, because as soon as you get it, you're going to be like, "Oh my God, that's really easy." And
by reading it, I'm assuming all the numbers you could use are in between those 2 points, right?
Yeah. So like the domain for this one, I'm just going to use letter D for domain, would be from -4 to +2.
Like all
yeah.
whatever that line crosses over.
Right. So from here, right. So from there to there. That's the domain. All of the x's.
Oh.
So like, cause like
not the line.
Yeah, no, it doesn't even matter where it crosses here and here. Cause look,
it doesn't matter where it goes up and down. It just matters the space that it takes up.
For the x's, yeah. Cause like, see this point right here? Like, it's some x and y right there, right?
Yeah.
X is the input, and it has an output, and that's where it is. Yeah, so it's not these points. Those would be x-intercepts. It's like any value you could use for x. So like here, this point right here, it's a coordinate, right? And there's an x value right there, and that y value is the output. So this is the x, and that's the y. So all of the x's, that's what the domain is. Now it's kind of weird, because most of what you've graphed so far is stuff that's linear, like 2x minus 4. And you know, that's going to look something like this.
Yeah.
You can put any number you want for x. Like there's no limitation. Like you can put anything you want. So the domain for this would be all real numbers. That would be the domain for that. And most of them are like that. Most of the domains like that we're going to deal with in this class, they're almost always all real numbers. Okay. So on a graph, you can find the domain by looking, right? You look at all the x's. You just see where are the values for x. So this one's from 2 to negative 4. All right.
I get that.
Got that? Okay. Now, for an equation, right? Let's say we had an equation. It asked you to define the range. For what we're going to learn in this class, it's going to be all real numbers. Real numbers, I don't know if you remember. Real numbers are square roots of positives. That's what real numbers are. Like if you have square root of a negative, it would be not real. Yeah, so I don't know, yeah. So when we say real numbers, that's what we're talking about. So it's all real numbers unless if you divide by x or you have a square root of x. And then we're going to have some limitation. So like this is like the short, this is like the kind of remember thing. So let me show you what I mean by this one right here. Let's say we had this function. I guess we're going to do range on another page. Scratch it out. Alright, so let's say we had this function right here. Now x is the input, right? So you just pick numbers, like if you're going to do a T-chart. Yeah, so if you're going to do a T-chart, you can use any number you want, except for you couldn't put in 0, because that's not a number. You can't divide by 0. That's undefined. So that's not a number, because 1 over 0 is not a number. So like what happens is we put 1 in, but it doesn't give us an output. So since if I put a 0 in for x, I don't get an output, that means that this number is not part of like the whole thing.
Okay, so you gotta put in something else.
Yeah. Yeah, you got to get something out, and that's nothing. That's not a number. So the domain for something like this is we could just write it like this: everything except x. Oh, sorry, except for 0. That would be the domain of that one. Do you see what I mean?
Yeah.
Yeah? All right, now check this out. Let's say I had another one. It was similar. Say it was x plus 1. Now in this one, you could actually put 0 here, because it would be 0 plus 1.
You still get 1.
Right.
You still get 1 over 1 is 1.
Right, but it can't be negative 1.
It can't be negative.
Right, because negative 1 plus 1 would be 0.
Oh, okay, you mean the x can't be negative.
The x cannot be negative 1.
Now when we're talking about x, we're talking about both x's, right?
Yeah, so like, yeah.
You put 1, you gotta put it to the other.
Yeah, so like actually that's what that means. Like, so what this means, let's see here. Okay, so with this side over here, this is really the same thing as y. That's what y is, right? But it's kind of cool because, man, like this is your input right here. Like this whole thing is y. Okay? Like the whole thing is y. But this part right here shows you the input. And so whatever number that goes there, you replace all of the x's with that number. Yeah. So the thing that's kind of cool about it is, like, let's say we had, like, I don't even know what this is. Let's say this is not the same function, like a different function. So what this really means, this whole thing means y is 3 when x is 2. That's how you read it.
This is the opposite.
Yeah,
I mean, it's crazy though, right? I mean, that's
it's really weird the way they,
know.
right? Cause
I
so
see it.
that's the input, and it equals 3 when you're done.
Y is 3
when x is 2. So like an example of what this could be would be, like, let's say we had f of x equals, I don't know, x plus 1.
Hola.
Hi. So that's what this could be. If x was 2, then y would be 3. Do you see what I mean? So like if you put 2, you get 2 plus 1, and that would be 3. So f of 2 is 3. Weird, right?
We're getting there. We're getting there.
Yeah, I know.
This is stuff I've never seen before.
Yeah, I know. That's why we gotta take our time. That's why I'm glad you asked about that. So yeah, this is called function notation. Function notation. So let's back up. Let's talk about that. I didn't know you hadn't seen that before.
Yeah.
Yeah.
I've seen this stuff.
Okay, so let's do that. That's good. Function notation. Okay. So you know how like if you have some equation like I don't know 3x minus 1,
Yeah.
right? And you know if you want to do a T-chart, like you could put a -4 in, and you do your math. You plug -4 in, you get -12 minus 1, you get -13, right?
Yeah.
It's kind of clunky. You have to write it all over the place. So the way function notation works, the first thing you gotta know is that what it's called is y is a function of x. And what that means is like y gets its value from whatever x is. So like x is the input. So you pick a number.
Yeah, 'cause the equation is 3x minus 1.
Yes. So what?
equals-
Yeah. Equals y. Right. So whatever x is, that's how you figure out what y is. Well, x is the input. It's the domain, right? So you put in a number and do some math, and that's what you get. So instead of writing like the whole thing like this and having to do a T-chart, here's what we say instead. And then this is the part that's weird. What this notation, what this symbol means is this. It means y is a function of x. And the way we use it is like instead of putting a -4 like a T-chart, what we'd do is we'd say, okay, what does y equal when x is -4? So this thing right here, it says what's y when x equals -4. That's what it means. And x equals -4. Hi, Celine.
Hi.
How's your day?
Long day.
Do you hope it snows?
Huh?
It might snow tonight.
You're what?
It might snow tonight.
Really?
Really?
I didn't know.
Yeah, we were just looking at the weather right now. Might snow.
Right.
Probably
Today
not.
or tomorrow?
Tonight, this morning at like 5 a.m. Might get a snow day. Probably not.
Nah.
Not unless some miracle happens, right?
No, that's to shut down the border.
Oh yeah, that's a mess, right? Oh yeah, I forgot those days. Yeah. Okay, so Ernesto, you see how this works?
Yep.
Like this is the same thing as like the T-chart. And so like you do the math, so that means that wherever you see an x, you replace it with a -4. And then you just do the math.
And the math is the same.
Math is the same. So that's -12 because you're multiplying. -1 is -13.
That's it.
So this says that when x is 4, y is -13.
Okay.
It's the same way as writing a coordinate like this. X is 4, y is
That's
-13.
okay.
Yeah. Weird, right?
I just want to ask the right question.
That's okay. You'll get it.
Like for example, what would be like okay, we get it. We hand us a test. What would be a question?
Oh, like
What would be a
yeah, like what are you gonna see, right?
Yeah, I want to.
So like it would say like this is our function. Okay, and it would say find. It might say something like find f of 2.
And then you just plug it in.
Just plug it in.
And do the math.
Do the math. So that the way you would do that, so that would be like the instructions. That's like what's typed up on the paper, right? So what you would do, you would say, oh, f of 2 equals 2 times 2 squared plus 1. That's 9. That's 9. So f of 2 equals 9. So Celine, what this means, like the x is the input, right? And this f of x, that's why we say f of x, like the f with the parentheses. It's not multiplying. It actually just means that y is a function of x. So what it means is whatever our input is, we can write it right there in the parentheses. So whatever value we want to replace x with, we just put it right there. And what that means is, it means you take your equation and you replace x with that number. That's it.
It looks easy, but
Mm-hmm. So on a graph,
Okay. Well, I'm pretty sure we're gonna get.
well, check this out. This is what the graph's going to look like. And so on a graph, what that would mean, like this is 1 and this is 2. So that would be 9 right there. This would be 2. That would be 9. That's what this says right here. When x is 2, y is 9. It's a coordinate. It's the same thing as a coordinate 2, 9.
So we can also be asked graph it
Yeah.
and
Yeah, it might say graph it,
graph it.
but then you just have to recognize that's the same thing as y.
Yeah, and after you get the 2 coordinates, you just
Make the
plug
graph.
in the 2 but is it gonna be a straight line?
This one wouldn't. We're going to learn that today too. Yeah. But so don't worry about the graph itself yet. I'll get
Okay,
you there.
okay.
Just this notation.
Yeah, I'm going.
I know, right? I know, right? It's like,
I started asking questions.
Yeah. Don't worry about the graph yet. We'll get you there. The graph's not that hard. Yeah. And the graphs are all going to be pretty straightforward. Okay, so do you see how function notation works now? Kinda. We'll use it. You'll get used to it. Like it's new, but it's something we're going to use a lot, and it'll become like second nature. It won't be a big deal. All right. Listo, Celine?
yeah.
Okay. So, let's see here. Let's say, so we were talking about domain, right?
Oh yeah, the range.
Yeah. So we haven't even got to range yet. We'll get to range. Don't worry. Domain's tricky. Dang it. Let's see here. Man.
There you go. I can see.
All right. There we go. So I don't want to move the table like I did last time, and then it just shuts off. And then I didn't do.
I was in my other class, and the guy, I don't know, he was gonna use it. So I don't know, it doesn't work somewhere. I guess the guy or the teacher messed it up. I didn't say nothing though.
Well, actually, I didn't actually do anything, and I emailed Gabe, and he came and looked at it too, and nothing happened.
He just said, well, someone must have messed with it.
Yeah, but
And I remember, Mr. Brown.
yeah, but I didn't. Yeah, I know. They actually had to send somebody out to fix it. It was some software issue. It was just a coincidence that it happened like that. It's just. And earlier today, I wasn't even doing anything, and the whole thing shut off.
I just thought it was funny when he started.
I know, right?
I was in the corner just like gilling his teeth. The whole class was like, why are you giving me? No.
Oh no, I heard a funny
I-
joke,
I-
right?
Yeah, it was something else.
Saw somebody fall down today.
They only knew.
Right. All right. So, domain. When you're asked about domain, what it's asking you is what number. So, like, say we have some function like this, right? I don't know what it is. Domain is asking, in one way to think about it, domain is asking what numbers could be used for x. And I think that question actually, I think that question, the way I say it like that, might be a little confusing. So maybe the better way to say it is like we said just a minute ago. We kind of hinted at this. And another way to say it is what value of x does not produce an output. And then, yeah. That won't be in the domain. Because, Celine, the thing that's tricky about domain is it's almost always everything. Almost every time the answer for domain, for what we're going to do in this class, almost always the answer is going to be the domain is everything. So it's kind of a weird question. So like, let's say I had this equation right here. Well, that's supposed to be a 2. 2x plus 4. Yeah? So domain, if the Celine asked you, right? So Celine, if the question asked you for the domain of this function right here, what it's really asking, it's really weird. It's saying, hey, what numbers could I use for x? And sometimes it's hard to think of what you could use. Sometimes it's easier to think about what you can't use. Now in this one, you can use any number you want, because you like any number you put in here, you can multiply by that number by 2 and then add 4 and you get another number. But so for this one, the domain, I'll put D for domain, is going to be all real numbers. The domain's all real numbers. But like for example, let's say we had a different function. Now Ernesto, when we use the letter G, it's the same exact thing, it's just like it's a different name. It's still a function, the notation works the same way. Sometimes we have more than one function at a time, and so we have to have a way to distinguish between them. Like you don't name your kids all the same name, although it'd be smart if you did, right? Yeah. Hey Johnny, clean your room. Johnny, shut up. Johnny, go to bed. Johnny, brush your teeth. Johnny, do your homework. Johnny, go, Johnny, shut up. Right, yeah. Yeah. So this is the same. But let's say we had this right here. Let's say we had x minus 4. Now, Ernesto might know what x can't be here. I don't know. We talked about one kind of like this a minute ago. But check this out, Celine. Here's the deal. I can, yes. So in the domain, I could use like 0, because here's why. If I did g of 0, I'd get 1 over 0 minus 4, and that equals negative 1/4. That's a number. That's no problem, right? I can use almost every single number. There's only one number I cannot use, and that's this one. I can't use 4, because if I put 4 right here, I get 4 minus 4, and that's 0. That's 1 over 0. That's not a number. You can't divide by 0. That's not a number. So does it make sense, Celine? Like when I say what number could you use for x that won't give you an output, like won't give you a number? So here, like we can't use 4 because that would give us not a number. So the domain for this one, and this is not a mathematically precise way of saying it, we could say it's correct. It's not how we say it in math, but we'll get to that later, okay? Right now I want to make sure we get the idea first. We could say everything but 4. The domain is all the numbers that you can think of except for the number 4.
So, I mean, and this is for when we don't get a function?
So no, they're going to give you this function right here. They're going to ask you for the domain. And so you have to figure out what number could I put in, and it will give me something that's not a number, like this.
Okay.
Let me show you another one. Let's use h of x. So we have f, a, g, and h, right? So let's say h of x was the square root of x. So you could use like 25, right? Because square root of 25 is a number. You could use 1, because 1's a number. You can even use 0, because the square root of 0 is 0. But you can't use a negative. Like for example, if I wanted to use negative 9, that's not a real number. There's not a real number times itself that equals negative 9. 3 times 3 is positive 9, and negative 3 times negative 3 is positive 9. And 3 times negative 3, that's not the same number. So that doesn't work either. So for this one, you can't put anything negative. This is 0 and bigger. 0 and all positive. So the domain here is nothing negative. Nothing negative is in the domain. Okay, Ernesto, you are not going to be asked to graph this at all, all for this class. You won't be asked to graph this. But I'm going to show you what the graph looks like, okay? So it goes like this. That's what the graph kind of looks like. Graph's a picture of all the answers, right? If you look at all the x's, it starts at 0, and then it just goes positive. There's nothing over here. There's no negative x's, because when you put a negative number in here, you don't get a number back. Well, not a real number. 99.9% of the time, your answer for domain is all real numbers. So Ernesto, you just got to think, is there something I could put in that would give me a not real number back?
Yeah, exactly.
Yep.
Just plug in, and pretty much what you gotta do is just start plugging in numbers.
Yeah, you just think about
the
it.
most obvious ones, obviously, is just plug them in, start doing the math.
So, yeah, you're right. Like, let's say we had this one. Let's say we had f of x equals x cubed. So the thing that's weird about x cubed is any number can be cubed. And you get another number back. You could put 0, you could put 1, you could put negative 4,000. And you can use any number you want. So the domain for this one is all real.
All real numbers.
Yeah. And since, I mean, you guys haven't been taught the difference between what real numbers and not real numbers are, it's a bad name, by the way. When they say real, like we think in like English, a real, like the opposite of real is like make-believe, and that's not what this means in math. So if you just say all numbers, for me, for right now, for what we know, that's good. So if you say all numbers, that's good, we're golden. Okay, but domain is talking about possible inputs. That's x values. So Celine, a minute ago, I showed Ernesto this graph, and it got kind of confusing because I put an x-axis on there, and that made it get kind of weird. So I'm not going to put a single x or y axis on this. Okay? I'm not. But we do know that x goes this way and y goes this way. Right? So check this out. You see this point right here? That's an x and a y. I don't know which way the origin is, but let's say it's this way. This would be the y, and this would be the x. So you see, even if the x-axis was all the way down here, that's still part of the domain because the x kind of maps to it. It's like a location. So for this one, we don't know what graph this is, but for this one, the domain, because you see the arrows say it's going to keep getting wider and wider, is all numbers. I think we got to try some in a few minutes, and then you'll see. You'll get the hang of it. You ready for range?
Oh.
We haven't even done range yet. It's almost the same idea, though. So we spent all our time talking about domain, right? We spent quite a bit of time, like 15 minutes, talking about domain. But here's how range works. Check this out. Range is the possible outputs.
Which is f of x, right?
Yeah, so like when you plug a number in and you get a number out, like what possible numbers could you get out?
And that's the range.
Uh-huh.
The numbers that you could get out.
The numbers you could get out. Celine's like, this is so much fun. It's confusing, right? It's weird.
Yeah.
It's weird. Once you get some experience with it, it gets a lot simpler.
It's not necessarily the number that comes out, it's just how many numbers.
Or what they could be. What they could be. So watch, let me give you an example. Let's say we had f of x equals x squared. Okay? Now, you can square every number you can square. You can square everything. So the domain is going to be everything. You good with that part? I hope. Maybe. If not, it's okay.
Yeah, it's everything.
But yeah, any number you want to square, you can square a number. Like always, you can square a number. So the domain is asking, what can I use for x? You can use everything. But watch what happens with the range. So let's do a little T-chart right here. I'm going to just draw a T-chart right around it, like this. Ready? I'm going to put x over here, and then I'm going to put a coordinate over here, like this. So we're gonna put a couple numbers in. I want you to get a feel for how this range thing's gonna work. So watch. Let's say I put in -4. So that would be, if I plugged in -4, that would give me -4 squared. That would give me -416. Do you see? Because -4 squared is 16. And then let's say I put in +4. I still get out 16. Let's put in 0. When I put in 0, 0 squared is 0. Okay, let's try -2. When I put in a -2, I get out +4. Because, okay, here's the thing. All squared numbers are even. Sorry, positive. I said even, I meant positive. All squared numbers are positive. There's no number squared that would be a negative. So that means, like, on a graph, like for y, these are the negative y's down here, right? You're never going to have one for this graph. You're never going to have anything less than 0. Do you see why, Ernesto? Because everything squared, every possible number you could use for x, when you square it, it's going to become positive. Because a negative number squared is positive, and a positive number squared is positive.
Okay.
So all of these numbers for y will always be positive. So the range is, man, I don't know if I want to say, I don't know how I want to say it. We'll just go ahead and do it. The range, we'll put R for range, and it'll be 0 to positive infinity. We could also say it this way.
Because they can be negative numbers, right?
Uh-huh. Right.
So obviously you gotta start from 0 and go up.
That's right. 0 and larger.
And that would be the range.
That's the range. The range is the y. What are the possible outputs? Celine, you want to see what this graph looks like? Why not, right? It's Tuesday. Let's live a little. Right? Okay, Celine. On Thursday, I waited till like 7:10 or so, and then
Yeah, I got
left.
here 10 minutes later.
Oh.
Oh, you did.
And when I got here.
Yeah, I was waiting. He emailed me, said he wasn't going to come, and so I thought maybe he emailed you, and he said, okay, I'm not going to go either. So I waited till like 10 after, and then I went. I even went in the car and I waited and I looked, and so I was like, oh well,
I'm sorry.
that's okay. I got to go home early. That's what the graph looks like. Here's why the graph's going to look like that. So we have 0, 0, right?
Mm-hmm.
We're going to have 1, 1, and we're going to have stuff like -3, 9, and we're going to have like 5, 25. Every number squared is positive. All the negative number squareds are positive. So what this arrow means is it's going to keep going like this. So eventually you would have like let's say that you had -10 out here. That's going to go up. Well, I guess it would hit all the way up here. You'd have -10, 100. So the range is going to be all positive numbers, 0 and bigger. And the domain's everything, because you can put any number you want. Ernesto, you're going to get it, and then you're going to forget it, and then you're going to get it, and then you're going to forget it. And then when you really, really get it, you're going to be like, oh, that's really easy.
Also.
No, you will. You'll be like, it's just new right now. That's all. It's just new. New things get confusing. So we'll visit this again in the future. Did I tell you guys about Blue's Clues?
Yeah, well.
Last semester? So, Celine, it's worth saying, because it's kind of can help you learn how to learn a little bit. Did you remember the show Blue's Clues?
Yeah.
Kids are little, they watch. So the episodes, they would show an episode, and then right after it, they'd show the same show. So it'd be on for an hour, but it's a half-hour show. So they'd show the show, they'd put the show on TV, and when it was over, they would do the same exact one. And the reason they did that is because they saw that people learn more when they see it the second time.
Mm-hmm.
So what we're going to do is we're going to go on from this, and then we're going to come back to it again later, and then you're going to be like, oh, I got it now.
Yeah.
Because it kind of like plants a seed of an idea, but they take a while for your brain to get around it. And, yeah. All right. Listo? Let's do this. All right. Man. We don't get to build snowmen here. We get to build them out of mud. Yeah. Yeah. All right. So where did my list go of the stuff we're doing today? Hi. I got all mixed up because I threw it around. Oh, it's right here. Check this out. So we talked about that. We'll come back to that later. Now let's talk about this. How to sketch a graph using a T-chart. Now, when we say graph, oh yeah, I got it right here, of a function, like these. Now you guys already know how to do, so on page, here I'm going to turn to page 168 too. 168 also. Now on page 168, it gives you a bunch of descriptions of a bunch of functions, and you guys already know how to do a couple of them. You already know how to do something that's like this, that's linear. Okay. Now it does tell you on the chart, it does tell you that the domain and the range are all real numbers. But I'm hoping that you don't have to memorize that you can kind of get an idea. So like 2x plus 3, like if I graph that, it's going to look something like this. Right? It's going to have a y-intercept of 3 and a slope of 2. So you go up 1, 2, up 1, 2, and over 1, and I missed, but you got the idea. Right? So any number you want, you can plug in here, and you can get any number out you want. So the domain is all real numbers. So we know how to do that. And the ones we don't know how to do are these kind over here. So we're going to talk about those. Which one do you want to do first, Ernesto? Absolute value, square, or cubic? I'll write them. Okay, good call. That's cubic. That's square. It's called a quadratic. An absolute value. So, yeah, that's right. I got you back. Way back. That's okay. I got you back. So we're going to do absolute value first. Absolute value is kind of weird. Because, is that okay for absolute value, ABS? Yeah? That's not anti-lock brakes. The anti-lock braking system.
Yeah.
That's not what that means. Yeah. So absolute value, the thing about absolute value is that it's always positive. Because it's always talking about a distance. So like the absolute value of -5 is 5. Yeah? No?
It's always positive. Right?
Always positive. Because it's asking, what it's really asking, like this is the absolute value, that's what those bars mean, and what it's asking is, hey, how far from 0 is this number? It's 5 spaces. And it's a distance, and distance is always positive. There's no such thing as a negative distance. So, yeah, absolute value is always positive. So that means, like, if you had a function that was the absolute value of x, you can use any number you want. 4x, like you can plug in everything. You can put in a negative, you can put it in 0, you can put it in 14, you can put it in 12.3. So the domain is, I'm just going to write the word everything. That is not a mathematically accurate example, but since we don't know what real numbers really are right now, we're just going to go with that. I'm more worried about the idea than the technicality for now. We'll get to the technicality later in the semester. So Lena, are you comfortable with the domain being everything?
Okay.
Because you can plug a number, like to be not in the domain, that means there's a number you could put here, and you could do the math, and you don't get a number back. Now you can take the absolute value of any number. Because a number is just on a number line, and it's just asking how far from 0 is it. That's all work. Okay, now the range is kind of weird. Range is the y's, it's the outputs. And you see, if I put in a -5, that's my input, right? See, my output's going to be positive.
So you gotta have a negative inside.
Well, you don't have to have a negative inside. You can put
Positive,
you can put a positive number inside. You can still get
positive.
Uh-huh.
Because 4 spaces.
Yeah, it's 4 away, right?
Yeah.
So the range, there's never going to have a negative number. You will never have a negative number because it's always going to be a positive because it's asking about a distance. So the range is 0 and bigger. We could say 0 to infinity if you wanted to. You could say 0 and all positive numbers. Yeah. So this is how these work for absolute value. Now they have a funky shape. The shape is a very harsh V, like that. Because you remember how for linear it's a line. For absolute value it's going to be a shape like that, a V. Oh yeah, it does show you that on that table on that page 168. It gives you the table. Yeah. So here's how we're going to graph them. Because, here's what I'm going to ask you to do when we graph these. Like if it was a quiz or something, this is what I would say. I would say graph by using a T-chart. And look, I'm going to tell you right now, and if I forget, and you remember, and I forget, you can call me on it and I'll fix it. So on a quiz, if I tell you to graph using a T-chart for these, for right now, I'll give you the numbers to use. Now later, like when we start doing, I think it's chapter 5, that's different. So this is for chapter 2. For chapter 2.3, for right now, if I ask you to graph something like this, I'll give you the numbers to use. So I'll give you something like, so let's say I say f of x equals the absolute value of x plus 1. Yeah, let's do that one. Absolute value of x plus 1. So I'll give you the numbers, like let's say we're going to use -2, -1, 0, and 1. Why not? Let's live a little. We'll do 5 numbers. That's pretty easy, right? I hope so. I think this one is. Because all you gotta do is plug it in, do the order of operations, take the absolute value. And we'll write our coordinates over here. So Ernesto, do you understand that we're going to plug these numbers in, we're going to get some coordinates, and then we're going to put those on a graph, and knowing what the shape is, we're going to figure out how it fits on the graph. Because the shape's going to look like this. It could be going down if it was a negative in the very front, but it's going to look like that. Okay, let's see here. That's weird. Which of these do you think holds more water? The one on the left or the one on the right?
Well, there's,
This one.
That one, but
This one
ours
holds.
is the same?
No, this one holds a lot more. This is a gallon. It's almost 4 liters, and this is exactly 3 liters. Isn't that weird?
Yeah.
But this one costs $1 more. The smaller one.
Really?
Yeah.
Oh,
Maybe because the gallon is different.
I bought that jug because when I'm done with it, I grow like lettuce and stuff inside in hydroponics, so I'm gonna cut the top off and grow lettuce in it. Yeah. That's why I bought it. All right. Here's what I got.
Wait.
Did I mess up?
From where you got the one?
This one?
Yeah.
Because if I put -2,
Uh-huh.
-2 plus 1, that gives me
Oh, it's 1. I'm sorry. I thought
No problem.
Heaven.
It's oh
Because of.
yeah. No, this is the absolute value bar.
Oh, okay.
There. Better.
Better.
Yeah. Ernesto, you good with that?
Yeah.
Yeah? Okay. Let's make a graph. So we're going to put all these dots on the graph. And then we're going to see if we can make these dots. We're going to see if we can make that shape out of those dots. Okay? Alright, now, let's see here. So I'm going to just go ahead and just do something real simple. We got small numbers, so 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's just a really small graph, right? It doesn't have to be very accurate. We're going to try to be neat, but it doesn't have to be perfect. So negative 2, 1, negative 2, 1 is right here. Let's see here. Negative 1, 0. That's right here. 0, 1 is right here. Oh, do you see? That looks like a V already. So the V is going to be right here. So 1, 2, 1, 2, and 2, 3. I don't have the whole V. I don't see what's over here, but I know it's going to look like that.
Yeah.
So I can tell from here how I'm going to make it. That's like the point of the V. It goes like that, like this over here, and it goes the other way. Celine, you see how that works? So I'm going to go ahead and do it like, whoa, got kind of missed there. Does that feel like something you can handle? The only thing you got to be careful of, Ernesto, is if it said something like this instead. Now that's different, because that's the 1 is on the outside. So you would do the operation here first, and then you would add 1 to your answer. Yep. So that's going to be different. That wouldn't be different.
Okay.
Yeah. How are you feeling with this so far? I feel like it's been a lot.
It's a lot, but it's going all right. I'm understanding.
Okay, so far so good.
Yeah.
All right. So this one right here, whoa. This one right here, it does have a domain and a range that's just like this. Okay?
Exactly, because everything, domain would be everything.
Everything. But this one's going to be different. This one's going to be different. So let me show you why. Okay. Let me show you why. So let's talk about. They're all laughing because they're going home. That's rude, isn't it? They're laughing at us, Celine.
No.
The thing they don't understand is we get to do math and they just get to go home and sleep. That didn't help, did it, Celine? Oh man, I'm sorry, Celine. See, that's why you should be a math teacher. You can torture people. Okay, so if we do a T-chart, same way, right? Let's say we do negative 2, negative 1, 0, 1, and 2. This is X. So I'll fill this one out. I'll just do all the maths because I am confident you can get all these numbers, right? The thing I want to get at is why this one has a different range. Yeah, plug it in. So this would be 2 plus 1 is 3. So negative 2, 3, right? And 1, the absolute value of negative 1 is 1, plus 1 is 2. So negative 1, 2, 0, 1, 1, 2, and 2, 3. You see? I'm fully confident you can get those. You might mess it up because you made a mistake, but you can get it. So let's take a look at the graph. Now it is still absolute value, so it's still going to be a V. Right? Still going to be a V. And here's the thing. So negative 2, 1, 2, 3. Negative 1, 2, 0, 1, 1, 2, 2, 3. See, the point is right there. The point is right there. The domain is still absolutely everything, but here, do you see the range? This is where the range stops. Here. Or you could say it starts there, depending on how you talk about it. Do you know what I mean? Like that's the smallest point in the range. So the range for this one is going to be 1 to infinity. Or you could say 1 and bigger. And again, right now, like, I don't really care how you say it as long as what you say is, right. So sometimes it's like that. What do you think, Celine? So range is all the y's, and if you look on the y-axis, there's nothing underneath here. But starting here, there's everything is above it. So like you pick a point here, it's got a y, you see? So that's the y, and it's got an x right here too. And since there's arrows, that means it keeps going like that forever. So it's going up and out forever. We doing Gucci? Gucci. All right. Is there anything better than Gucci other than Circle K coffee? You don't like Circle K coffee?
Oh yeah, I love Circle K coffee.
Oh yeah?
I
Huh?
That's what I eat.
That's what I hear all the time. People say they love Circle K coffee. I've never had it.
You never had it?
Nope.
No? Why?
Because I'm spoiled.
You get Starbucks.
No, I don't even do that.
No?
Like back in the spring, no, in the fall, early fall, my wife bought me a fancy espresso machine, so I make espresso at home. So I don't do that. And it's cheaper. Like a bag of really good coffee is like the same as 2 drinks at Starbucks. And then that gives me I usually drink 4 every morning, every day of the week. And so then that's like what, 28 drinks for a week, and it costs what 2 drinks at Starbucks would cost for 28. Yeah. Hi, Jenny.
I just buy a cup on Monday $1.50, and then I take a real triple for 89 cents.
Yeah.
Yeah,
That works. That works.
I like the what is it? The
The
Colombian.
Colombian.
Dark bread.
Okay, we got 2 more.
Alright.
Dos más. And the other 2 are going to work almost the same way. So we'll do the squared next, the squared function. Because the squared's really similar to this. In fact, yeah, it's a thing that's called a parabola. So it's kind of like a U and a V had a baby. So it's kind of like a V, except these aren't in reality these aren't actually straight. They're curved, whereas these are going to be straight. And this is definitely not a point at the bottom. It's a curve at the bottom. We're going to learn a lot about this later, so I'm not going to worry about it too much for right now. I'll teach you all those details, but basically when it's x squared, it's a shape that's called a parabola. And it's curved at the bottom, and the sides are curved, but they look straight because they start growing. What happens is they start growing up really, really fast. Yeah. So squareds look like that. Now, if for both of these, if there was a negative in the front, they could actually go upside down. But I don't think, I just looked earlier, but I don't think I don't think we do any of those. But they could happen, and we might do them later. But I just wanted to mention it, Celine, so that if you end up with something that's really weird and it's upside down, it doesn't mean you're wrong. You could be right. Yeah. Okay, so x squared is a parabola, and the domain and the range, they're same as absolute value. And it works the same exact way. Because anything squared is positive. Absolute value of anything is positive. Yeah. Now, the domain for linear, square, cubic, and absolute value. It's always going to be all real numbers. So for all of these, for the domain for these, it's really, really easy. It's only going to get weird if you have a square root or you're dividing by x. But for all of these, so just lay your mind at ease for the domain for these. It's going to be all real numbers. The range can change. Okay? So the range can change. You have to find the smallest point. All right. Is how we did the last one, like this kind. Did that help you guys? Did that help you see how this worked?
Yeah.
Yeah? What about you, Celine? Did doing the absolute value with the T-chart and then doing the graph help you see how it worked? Because we did the T-chart and then we had to put the points on the graph and then see how to make the graph look like the shape. That's what I'd like to do with this one too. So let's do a T-chart. Let's find some points. Let's do the most basic one. Okay, so the most basic is just plain old X square. I know that's not how you say squared in Spanish, but it's fun to say Spanglish. Yeah, I know. It's more fun to say a square. It's Spanglish, right? Yeah, Spanglish. Okay, so let's do a T-chart. Let's do X over here. X comma Y over here. And just like last time, I'll give you for now. Later for these you won't have a T-chart, but for now until in chapter 2, I'll give you the numbers for the T-chart. I know, me too. Alright, so we're going to put all these on there. We're going to put the dots on there first, and then we're going to see how can we make those dots look like that. Alright, that's basically the game we're playing. So, -2, 4, -1, 1, 0, 0. You see how this one goes up way faster, because like the other one, -2 was -2, -2, -3, -3, negative. It was like made a straight line. But like this one, next thing would be 3, 9, which would be like way up here. And then 4, 16, which would be almost off the page. So you see, it grows up like super fast. And then it turns around at 0 because, you know, you take a positive number and you square it. And yeah, so I have these dots here. This one I made up. Like it's 3, 9, but yeah. So I've got these dots here and I have to make it look like that. It's tricky because it's curved at the bottom, so you got to be kind of careful. Oh man, it's all Schwecko over there, but yeah, that's okay. That's it. Ernesto, do you see how the domain is going to be everything? You can square any number you want, but the range
is going to be.
It's going to be everything from here up, so 0 and larger.
Because the other one was from 1, right?
The other one was at 1 because the point was right here. And so instead of being here, it was here. Yeah, in fact, let's see here. So check this out. The first absolute value we did, it looked like this. And so the smallest point was right here. It was at 0, and it went up from there. It doesn't matter where the 0 is, left or right. It only matters, you know, this way. We're looking up and down. So this one's very much like that. Yeah. But then we did, oh, I think it's on the other side. Then we did this right here, you see? And now it's not at 0, it's at 1, and that's why the range was 1 and bigger instead of 0 and bigger. That's the part that you're gonna have to figure out a little bit on your homework.
Yeah.
Okay, Celine, you ready?
Yeah.
Okay, Celine, I'm gonna put one here. I want you guys to try it. It's gonna be like this, a little different. Yeah, we're going to graph it, and then we're going to find the range. So graph and range. Now the domain's all real numbers, so we don't have to worry about that. So let's do f of x equals x squared minus 1. And we'll use our same numbers. -2, -1, 0, 1, and 2. And here we have x comma y.
Oh, so we're doing square one, right?
Yeah, squared
I was
minus,
looking for another, okay.
yeah, squared minus 1. Did you get all those points, Celine? Yeah, you know you got to graph.
I didn't get those points, though. No, I didn't even get that graph.
But did you square first and then subtract 1? You did something silly.
Your range gonna be -1 enough?
That's right. Dang. You
Yeah, I
got
just
this.
didn't multiply, right?
Yeah, it just times itself and then subtract 1 after that. I bet you messed up. What did you get for -2?
Oh, I got that.
Oh.
Instead of -1, I have -1, -1.
Oh.
Yeah.
Yeah, so -1 squared is 1. 1 minus 1 is 0.
0.
Yeah. Oh,
And then on 1,
You have.
I got 1, 1.
Yeah, you know what that's called? That's called working all day and then trying to do math at night. That's what that's called. That happens. All right, no big deal. So Celine, you made me very happy with 2 things. Number 1, you got the shape, because the shape can be tricky, like how to draw the parabola with these points. So that's the bottom. So it's going to look kind of like that. And you're right. The range is -1 and up, or bigger, whatever you want to say. That's right.
For now, I got it.
You got it.
For now.
For now. For now. And that's the one that looks the ugliest is the easiest. Okay, linear is the easiest. But the cubic one, the exponent of 3, is the easiest. Because for a cubic, the range is always the same. and the domain is always the same. So you ready to do it? Let's do it. Last one, and then we're DONE finished. I know that makes you sad. I know that you like to hang out with me. I know this is fun. But cubic, that's something like this. Cubic. F of x equals x cubed. Cubed means times itself 3 times, right? So like 2, like so for example, like just to make sure we're clear, that would be 8. It's 2 times 2 times 2 is 8. Right? So this is the input, 2. Do the math, you get 8. Domain and range for both of these always never changes for cubic. All real numbers, or all numbers you could say for what we know right now. Negative infinity to positive infinity. And that's never going to change. So like you know how for absolute values sometimes the range will change. For quadratic, for squared functions sometimes the range will change. For this one, always going to be the same. The shape. The shape kind of looks like a sideways S. Like that. Yeah. And like this would be the origin. It gets kind of flat in the middle right here. It gets kind of flat. It looks like a straight line in between here and here, but it's not. And the thing is, here's the deal. Watch this. Do you see how fast the numbers grow? Because when you're cubing them, they go up super fast. So this, it starts looking like it's going straight up and down. But you can put any number you want in for the domain. So Ernesto, the only issue is going to be not to mess up the T-chart.
Yeah.
Right?
Yeah.
So I'll give you the numbers. So like let's just do one, and you guys do this one, and I think that will be it for the day. Let's do x cubed plus 2. And then here I'll give you the numbers that we're going to use. Let's do negative 2, negative 1, 0, 1, 2. So let's make a graph of that. And that will be it. I know it makes you sad. Oh, I know it makes you sad.